Thank you. Hello, everyone. Welcome to this talk about Docker containers in Java. And this talk is basically the things that we should know and the things that we should avoid before putting our Java and JVM application inside a container and put it into production. So before jumping into the slide, a quick introduction about me. I'm Mohammed. I work for a DevOps company in Morocco called XHub. So the easiest way to find me is on Twitter. I'm a Twitter fanboy. And my Twitter handle is Laytoon. Or if you have any question, please feel free to send through email. So my talk today will highlight the story of a Java developer who has been working with Java for a couple of years now, and he truly believes in the power and limit of codes. And he starts hearing about this relatively new technology called containers, and he wants to start playing with it, see what limitations it brings and what features it offers. So my talk today, it starts with somehow the philosophical question, is it a good idea to put actually a Java or a JVM application inside a container? We will discuss afterward how to create effective Docker Java images that are both smaller, faster, and secure. We will discuss the tools and libraries that we should know that make working with containers in Java a lot more easier. We will see the things that we should know and the things that we should avoid before deploying our Java container into production. And finally, I will discuss all the Java feature that has been added to Java to make it more container aware. Oops. OK, so containers nowadays are everywhere. And they are used for a wide range of applications. We can find them from fast serverless applications to huge monolith enterprise application. And that's because containers offer a number of great benefits. They have a rich ecosystem backed by many players that offer solutions like Kubernetes, Swarm, and stuff that make deployment more easy, scaling our containers a lot more easier. Containers also advocate the microservices and decoupled architecture. They make positive use of immutability, the concepts of immutability and declarative configuration. And because of this lightweight utilization that containers offer, it makes resources utilization a lot more efficient. And the backbone technology behind this lightweight utilization is basically two things, which are namespaces and Cgroups. So basically, namespaces are used for providing different isolated view on the system. So each process can have its own view on different namespaces, like user ID, network ID, and so on and so forth. Cgroups, on the other hand, are used for providing limiting and measuring for the resources that can be used by a process, like memory, CPU, network I/O, and block I/O, and so on. So in Cgroups, each subsystem, which are memory, CPU, network I/O, and so on, form a tree structure or a hierarchy of nodes. And each process belongs to one node and one node only in each hierarchy. So given a process, it will belong for one node for CPU, one node for network I/O, one node for block I/O, and so on and so forth. So initially, when the system boots, there's only one node, one big node, and the first processes belongs to this node. So if you think about it, basically, if you are not using containers yet, you are just using one big container with no limitation and no constraint. That's, of course, if you are using like Linux, which is probably in your production system. And then Pharaoh asked himself, is it a good idea actually to put a Java application inside a container, especially that the JVM offers by itself a great number of benefits. The JVM has a rich ecosystem. The JVMs offer many tools that you are familiar with. The JVMs ensures security, since there are many companies that are running mission-critical applications using Java and JVM. And the JVM itself is OS agnostic and runtime adaptive, which means that the JVM will try to tune itself, and adapt itself to ensure the best performance in the execution environment. However, Pharaoh decided to give it a try, and after reading a couple of tutorials, he came up with this Dockerfile. It is obviously not the best Dockerfile that you can find out there, but he built it, he ran it, everything is working fine and perfectly. And Pharaoh asked himself, what I actually need from my container image production. What characteristic my production container needs to have? And the answer is basically three things. I need a good base image that contains my runtime dependencies. I need my image to be as small as possible. And I need my container, my production container, to have a small, a fast startup. So first things first, and when we're talking about good base image in the context of the Java and the JVM, we obviously talk about the Java runtime itself. And if you have been following the trends and the news in the Java ecosystem lately, there were a huge discussion about the future in Java, especially after the new release cadence, which is now 6-month based, and the new licensing from Oracle. But Java is still free, and there are many providers that are offering that for free. And if you need support, there are many companies that are offering that as well. And as Dr. Venkat Subramanian loves to say, there is no such thing as end of life if you have enough money. So that was for the base image. The second thing I need from my image container is to be as small as possible. And for that, there are a couple of techniques that can be followed from both the Java side and the Docker side. So from the Java side, we can use a new feature introduced back in Java 9, which is Java modularity or Project Jigsaw. And this feature enables us to tailor the JVM to select only the modules that we need during runtime, and enables us also to make our own custom GRE, putting the JVM in a strict diet. Also, techniques like code refactoring and code review helps to reduce the logic complexity, the overall lines of code, and detect what dependencies we are using, or detect using a whole dependency just for a small utility function. And talking about dependencies, there are tools both in the JDK itself, like GDEPs, and tools available in both Maven and Gradle that help to detect what are the zombie dependencies, the dependencies that we are not effectively using during runtime, and what are those that that my application need to run. So from the Docker side, there are a couple of steps that we can follow to generate a smaller image, and starting by using a smaller base image. And as we will see in the future slides, the smaller the base image is, the smaller your final image will be. Also, understanding the concepts of layer of caching of Docker helps to reduce the final image size. But generally speaking, is it a good idea to combine the related comments into your Docker file and separate the unrelated comments? Also, cleaning up right away. And while working with Docker, it is a general practice to download an archive, extract it, edit the files, do some modification with the files, maybe move the files in another directory, and then forgot to remove this archive. So removing this kind of files, as well as some caching directories and some log directories, helps to reduce the final image size. Also using Docker ignore, and Docker ignore is very similar to git ignore, but it's for the context of Docker. And depending on your application, you might want to ignore some kind of files, like the .git file, the log files, some temporary files. And one nice side effect of using Docker ignore is that it helps to speed up the build process, since the context, which are the images, which are the files that need to be sent from the Docker daemon, to Docker CLI, sorry, to the Docker daemon are now fewer. Also using multi-stage build, and this is a feature introduced in a couple of years back in Docker, and it helps to separate the build stage or stages from our production image, keeping our production image clean without the unnecessary build files. And finally, using Docker Squash, and Docker Squash is a utility function that enables us to squash the image layers in order to generate a new image that works exactly as the original one, but with a smaller size. And there is an experimental option in Docker command, which is --squash, which does exactly the same thing. And when we mentioned using a small base image, one Linux distribution comes to mind is Alpine. And Alpine is the ideal Linux distribution for many applications out there, especially in the context of containers. And Alpine is a very lightweight Linux distribution. Its size is almost 4 megs, and it's based on top of musclelipsy and busybox. So very briefly, busybox combines tiny version of common Unix utilities into one single executable, and musclelipsy is an implementation of libc, which is like the standard C library, and that's basically the standardized interface between the user land and the kernel, doing such things like opening files, network connections, and many other operating system utilities. However, there is one big difference between Alpine and other common Linux distributions that we are familiar with, which is, while Alpine is based on musclelipsy, other Linux distributions are based on glibc, which means that C and C++ code that is compiled with musclibc will not work and on glibc, and vice versa. And you may be wondering why we are talking about C and C++ in somehow a Java talk. And that's because we, as Java developer, we are using a software that has a lot of C and C++ code to do a lot of its work, which is the JVM itself. So the JVM has been already ported to glibc, but not yet to muscle. And in order to ensure a transparent run of the JVM to muscle, there is some modification that needs to be made on the code, on the JVM itself. And luckily, such project exists, and we call it Project Portola. And you can download it and start playing with it as part of the early access of Java 14. And this project has started as part of Java 12 and has been pushed to Java 13 and Java 14 since it's not yet production ready and it needs a lot of testing. And you might find on the internet many images that are based on Alpine, like the Adobe OpenJDK repository. And what those guys are doing, they are just adding the glibc Alpine package on top of Alpine. They are not using Project Portola or any Java JVM port of the JVM, sorry. And this slide shows clearly the impact of the smaller base image on the overall final image. And the winner is clearly the OpenJDK 8 JERE based on Alpine, followed by two other images of Java 8 and Java 11 coming from Google Cloud Registry. And those images are part of a cool project from Google called Distroless Container Image. And this project aims to create images that contain only our application and its runtime dependencies, restricting what's inside the application, what's inside the container to exactly what our application needs to perform its function. It does not contain many things that you are familiar with common Unix utilities, such as package manager, shells, and other debugging stuff. So this project is, those images are built using Google Bazel tool. They support many languages, including Java, of course. And the nice thing about this project is the base image they are using. It is a lightweight Linux distribution. Its size, it's HMix, and it's glibc based, which can be considered as a nice alternative to Alpine. And someone would ask, why should I care about making my images smaller? And the short answer is the smaller is better. And the long answer is each time you are, everything in your container is something that the performance needs to be tracked and needs to be scanned for common vulnerabilities. And each time you are pushing or pulling your image, you are incurring expenses in terms of data transfer costs and time. And finally, the smaller your image is, the fewer components it contains, the smaller the service attack. And last but not least, what I need from a container, my production container, to have a fast startup. And there is a common belief that the JVM has a slow startup, and that's because the JVM is a complex piece of software engineering that does a lot of things before executing your bytecode. But the issue is known, and the Java community started the work to make the startup time of the JVM a lot more faster. And the easiest way to benefit from that is to start using the latest version of Java, or at least using Java 11, as it has by far the fastest startup compared to Java 8 and Java 9. Other techniques exist as well, like class data sharing, ahead-of-time compilation, and native, or a cool project from Oracle Labs called GraalVM. And actually, let's see those things in action. I don't know if you have enough time for demos, but this project is simply a simple niche project. And what it does, basically, it's start a niche server, and then once it starts, the system exits. And it's very simple. Once the application is very simple, when it receives a request, it's basically a reward. But the project contains a lot of branches that basically use techniques either to improve the startup time or reduce the size of our image. So we talked about CDS, and CDS stands for class data sharing. Come on, class data sharing. And a class data sharing is when you execute the bytecode, when you want to execute a class file, the JVM looks for the class name. It does a lot of preparatory steps. So it looks for the class name in the jar, it loads the bytecode, it verifies the bytecode, then it pulls it into internal data structure. This takes some time, and it is more noticeable when the JVM start the applications, and it's need to load a lot of hundred or thousands of class files. So, but the thing is, if the code inside the jar does not change, the JVM need to perform the same exact preparatory step to generate the same exact class data. And here comes the idea of class data sharing, which aims to generate this data once, put it into an archive, and then reuse it between for future launches and share it between multiple JVM instances and multiple containers. And here I'm using Java 13, and Java 13 comes with a new feature, which is dynamic CDC, and which basically we can specify an option, archive class at exit, would generate this class data when the application exits, and then I can reuse it into my production image, specifying the archive file. If you are not using Java 13, what we do normally is to generate the list of application classes, and then using the share dump command, the share dump option, sorry, and dump load class list to generate this archive and reuse it in production. That was class data sharing. Another technique we can use as well is ahead of time compilation, and ahead of time compilation is very similar to JIT. How many of you are familiar with Java just-in-time compiler in Java? So basically, just-in-time compiler, based on some profiling information the JVM collects during runtime. So the JVM compile the most executed code into native code, and that enables the JVM to generate highly optimized code and improve peak performance. However, during startup time, the JVM does not benefit from JIT compilation since the code is not yet JIT compiled. And here's come ahead of time compilation, which is basically we use the tool JEUTC command, which enables us to specify the code bytes of code that we need to execute ahead of time, and the JVM can use it when it wants to launch. And it has a lot of options. We can specify the list of methods we need to compile, the modules that we need to compile, and even provide it with a jar file. And then, once we have our native file, we can specify it in my production image, and then the JVM, if it finds this method already compiled, it will load it instead of using the old alternative. And finally, to improve startup time, we can use a cool project from Oracle Lab, which is called GraalVM. And GraalVM is a cool project that is used in production already by Twitter and many other companies. And it's basically a universal virtual machine for multiple languages like JavaScript, Ruby, and many JVM languages, of course. But what excites people about GraalVM is a sub-project called Substrate VM, which enables us to compile our Java application ahead of time to native code. And it will generate a self-contained native code, and we can execute our application without even the need of a JVM or JRE. So here I'm using always the multi-stage build and based on the GraalVM Community Edition, and I'm downloading the native image tool, and then using the native image tool, I generated a self-contained native library that I use it in my production image. And this native image, or this native application, does not need a JVM and does not JIT compilation, which reduce the memory footprint and improve drastically the startup time. That was for optimizing the startup time, but there are other things that we can use to optimize the size of our image. As I mentioned it in the presentation, we can use G-Link, which is part of the project Jigsaw, and we can tailor the JVM and select the modules that we need, and generate my custom JDK, which is reaching runtime here. And then using the GCR, the Distroless-based image, I use only this customized, my own JRE to run my application, which reduce the size of my image. And I have here a small benchmarking scripts which measure the startup time of my application and also the size of it. And if I run it, I will have something similar to that, which regarding startup time, compared to my plain image, which is the master image, ahead of time compilation and class data sharing, we see some relatively small improvements, but compared to Graal, while using Graal, we see a lot of improvements. And to reduce this image size, we see some improvements while using Alpine and Project Jigsaw, and also using Graal VM. So that was for techniques to both either to improve startup time or my image size. And also containers are, as I've said, everywhere, and they are more popular than they became today, the executables of the cloud. However, our developer, Faro, our friend, thinks that container added a new layer of complexity and makes it a bit more harder for developers to generate this new unit of deployment, and was wondering if we can reuse the same good old tools that we are familiar with as Java developer to generate this new unit of deployment. And luckily, such project exists in both Maven and Gradle. So the easiest way to achieve that in Maven is directly to embed Docker comments inside Maven exec plugin. However, this solution is not so elegant, and other more sophisticated, more robust plugin exists, such as a DockerFile Maven plugin from Spotify or the Fabric 8 Maven plugin from Fabric 8 community. And if you are using Gradle, other solution exists as well that does similarly the same thing. And another cool project exists, this time from Google. It's called Google Jib. And Jib is an open source pure Java library that's available both in Maven and Gradle. And it enables us to generate Docker images without the need of a Docker file, and even without the need even to have Docker daemon installed in our machine. And what Jib basically does is somehow similar to this Docker file. So Jib understands our application, separate it into multiple layers, put the files that are more likely to change on the bottom, and the files that are less likely to change on the top. And that's ensure reproducibility, since if the files, our codes does not change, the generated image will be the same, and help to speed up the build process, especially incremental builds. Another cool project, this time from Docker, is called BuildKit. And the number one complaint of Java developer while working with containers is mounting the local repository, our Maven repository in the containers to run our build. And the hack was to mount using volumes our local repository with the repository inside Maven, but that creates some craziness with the permission file. What BuildKit comes with is extending the Docker run command and introducing a mount type. And there is a type of cache, which is called a type of mount, which is called cache, that can be used to as a solution to this issue. And BuildKit offers a number of great features as well. It comes with a concurrent build graph server, which can execute Docker file commands in parallel. And it also keeps track of modified files into your code. So it only compiles the files that change it. It's an experimental feature and an option feature that you can enable in your Docker Sense version 1809. Another important practice while working with containers is image versioning. And there are common techniques that we can use to achieve that, and nothing stops you from combining those comments. And one thing to keep in mind is to avoid using latest. As stated in the Kubernetes documentation, since it is not dynamic, which means it will not be added if you do not specify it in your tag image or keep it empty. It is not descriptive, since orchestration tools such as Kubernetes and Swarm need to have separate versions to update version or rollback, and it makes their life a lot more harder if you are using latest. And it's easily overwritten, since it's default tag. It's easily vulnerable to human error. Another important practice is security, and this needs a session on its own, but my goal here is just to give you some small bullet points to keep in mind while working with containers, starting with knowing what's inside your container. And you need, especially if you're using third-party containers, you need to make sure that those containers that does not does not download anything during runtime. You have also to run SAS tools and vulnerability scavenger tools, both for your code and for your image. And there are many open source and paid solutions that help you achieve that. And you have to start using Docker Content Tasks. And when it's enabled, the Docker daemon will automatically sign your image using the publisher private key, and when a later user wants to pull the image, the Docker daemon will verify using the publisher private key, public key, sorry, for authenticity, integrity, publishing date, and so on. Another important principle is least privilege principle, and this principle advocates that we need to run our processes and containers with the least minimum access right and resources that needs to perform its function. A couple of steps can be followed to achieve that, starting with making sure that we are not running our processes inside our container as root. So even an attacker succeeds to exploit a vulnerability that does not give him a root access. Also, running our file system as read-only, so an attacker does not modify the file or change the files on save malicious script inside our container. And finally, limiting the resources that can be used by a process to avoid some kind of attacks like those attacks. Also, as explained previously, having a minimal container OS helps to reduce the surface attack. And finally, having monitoring and auditing tools in place helps to detect unusual behavior and trigger alerts. Another practice in software engineering is testing, and testing helps to verifies that the code we wrote works according to specification. However, it is hard to achieve this real isolated testing environment, since our application, especially in a microservice world, needs to communicate with other services, like sending emails, connecting to databases, communication with other services, and thus the need to API or brokers. Docker helped to ease this process, and one cool Java library that's worth mentioning is test containers, and it integrates easily with the JVM testing framework that we are familiar with, and it comes with a great number of benefits. It's easy to use, it provides lightweight throwaway instances of common databases, port randomization, and it automatically cleans up the container after the JVM shutdown. So with that, Furro seemed happy and want to deploy its application into production. And I have only 3 minutes left, and I have a demo here, but I'm not sure that I will run it. But basically, what the demo will do is, normally when we are using orchestration tools to deploy our application into production, it enables us to specify limitations for our container. And we will simulate that using our application. So it's basically a pit store application. It's basically a pit store application based on Java 8, and I will run it using only 250 megs of memory, and I'm going to give it a name actually. 250. And what limitation basically do is to ensure that our container will use only the amount of memory that we are given to it. But the thing is, the JVM, the previous version of JVM, are not completely aware of this new limitation that Cgroups offers, and the application will actually fail to start. Hopefully. Okay. Okay. But you can like see here that even if I mentioned that the application have only to use 250 megs, the JVM decided that it gives the maximum heap size as 2 gigs, and the application finally failed to start. And if we inspect the container, we will see that it received a kill signal from the daemon, from the Docker daemon. And that's because it used more memory than it allowed to do. And if you are using Kubernetes or some orchestration tool, you will see your containers restarting and restarting and restarting, and it's enabled to achieve a consistent state. And that's because the JVM is not completely aware of the cgroups constraint or containers constraint. And the first part of the question is that the containerization movement started back in 2000, and when Docker appeared in 2013, the containerization movement exploded in popularity. However, Java was here since 1997, and when Docker first appeared in 2013, Java 7 was already out, and the work on Java 8 already started. And that's explained why the JVM is not completely container aware. Another part of the question is JVM ergonomics, and as we have seen in the demo, the JVM try to, if no tuning parameters were passed to it, the JVM will try to tune itself and to adapt itself to ensure the best performance in the execution environment. And it does that by collecting information from the underlying host, such as memory, the number of CPU, and so on. But if the JVM fails to get those information or get them from the wrong place, so this nice feature will turn out to be a nightmare. And in the demo, I presented an example of memory, but the same thing applies for CPUs. And if the memory fails to give the good information of CPU, this will impact its internal threading, some popular APIs like Fortune API and Stream API, and some other popular Java frameworks. So the issue is now when the Java community started to work to make the JVM more container aware. Unfortunately, if you're using Java Update 121, as I have used it, or before, the JVM is not container aware, and you need to pass that parameter by yourself, or you can use a nice script from the Fabric 8 community. This shows all the improvements that the JVM community comes with to make the JVM more container aware from Java 8 till Java 12. My time is up. And it is never a good idea to put your application into production without having monitoring tools in place. So there are many tools built into JDK that helps to keep an eye on how the JVM is behaving. And there are, from Docker side, there are many tools that enables us to look how our container is doing. So final word, is it a good idea to put a Java application inside our container? Yes, definitely, but keep in mind that Java is not completely yet container aware, especially the previous version of Java. Use as far as you can latest version of Java, and keep in mind that Java has a rich ecosystem with many tools that make working with Java a lot more easier. And with that, thank you.
Thank you, thank you. We have a couple of questions, but we'll probably ask you two of those. Those are viral. Okay, so, how about the first one? Do we need to restrict Java memory usage in Docker?
Yes, absolutely. That's one of the great feature of using containers, which is limiting the memory and CPU that your container can use, so you can have more dense packaging and improve the utilization of your server.
Thank you. And another one. What tools are you recommend for integration, testing of microservice system on Docker?
I mentioned test containers, which is it's a great tool. It's like framework specific. If you are using Spring Boot for your microservices, it comes with a great number of Spring Boot was created with testing in mind since the first day, and it have a solid testing frameworks. If you are using other things, I believe that Aquarium, I forgot the name, but it's a solid testing framework as well that work with containers, and you can test your microservices.
Thank you. We have a couple of more, but let's leave those for a little break a bit later. Well, for example, people want to know where they can get the slides and lots of other things. So probably going to be discussing this a bit later. So thank you, ladies and gentlemen, Mohammed.
Thank you.